So in this video, I'll be showing you a indoor sunset. For that, in a beaker, I am taking 1.2 grams of sodium thiosulfate and dissolving it in 80 ml of water. Now to make the sun, I am using a flashlight and placing it in my ring stand. On top of it, I am placing a magnifying glass, and on top of the magnifying glass I am also putting a CD and a black chart paper into which I have made a hole. When the flashlight is turned on, a spot is formed on the ceiling. This is our sun. Now I place the beaker which had sodium thiosulfate solution on the top of that hole, and to this I will be adding 10 ml of 1 molar hydrochloric acid. Now on turning on the flashlight, you can see that light passes through the solution and forms a white colored spot which is our sun on the ceiling. So this is our sun which is now white in color. Now to this solution I will be adding the 10 ml of 1 molar hydrochloric acid and give it a mix. On mixing, reaction starts and small particles of sulfur are being precipitated. You can see that this solution is now scattering blue colored light, and the sun is going from white color to a yellow color. You can see that our sun has turned yellow in color, and now it is going from yellow to red, and now the sun is not even visible. This beaker is a representation of the sky. The reaction went way faster than I thought. So this time I am adding 0.5 grams of sodium thiosulfate into 80 ml of water. This time on top of the beaker I am adding one more CD with black chart paper to make a sharp spot. Now the spot is much sharper than before. Now to this I am adding 5 ml of 1 molar hydrochloric acid. I will give it a stir and switch off the light. Now this is the sky. Initially you can see no scattering is taking place, so our sun is white in color like it happens at 12 p.m. But slowly sulfur starts getting precipitated. So the particles are small, so they only scatter blue colored light. That's why our sky appears blue in color, that you can see, and the sun starts turning yellow. You can see this is the sky and it is blue in color, and our sun is now getting yellow. Now slowly and gradually the particles will also scatter the yellow light also, and the sun will slowly and gradually go to a reddish color, and finally the particles will get big enough to scatter the light completely, and we will not even able to see the sun. So before disappearing, our sun appears red in color, but our camera was not able to capture the color properly because the color was very faint. In the end, you can see that our sky appears white because now it is scattering all the light. So this time, to make the spot much sharper, I am using another magnifying glass on top of the CD. Now our spot appears much sharper than before, but now it does not look like a sun anymore. Anyways, I will still proceed with the reaction. So when these two solutions are mixed, hydrochloric acid reacts with sodium thiosulfate to form colloidal sulfur. So slowly and gradually, the particle size of sulfur increases. In the beginning, the particles are very small, so they scatter only blue colored light, which has a lower wavelength, and that is the reason that our sky appears blue. But slowly and gradually, as the particle size increases, they also scatter yellow colored light. That's why the sky in the middle appears yellow in color, and our sun changes color from white to yellow to orange to red, and then finally we stop seeing the sun. So this also happens during the natural sunset. At noon, the sun is at vertical position, so the light has to travel least distance in the atmosphere. That's why sun appears white and bright. But as sun starts going towards the horizon, the light has to cover a longer distance in the atmosphere. Therefore, it gets much more scattered, and slowly the sun starts appearing yellow in color. The more the sun shifts towards the horizon, light has to cover more distance in the atmosphere and gets more scattered. Therefore, the observer observes the sun to be red in color just before the sunset. And sometimes you not even see the sun setting in the horizon. Just before setting, you stop seeing the sun. You can see that the flashlight appears red in color when I'm showing it from the top. So this time, to increase the column of the sky, I used a measuring cylinder instead of a beaker and used the same arrangement. Mixed hydrochloric acid into sodium thiosulfate solution and then poured the mixture into the measuring cylinder. After the solution was poured, immediately flashlight was lit and the light was closed. And you can see that there are some dust particles in the measuring cylinder which are scattering white light. But now, after some time, the sky turned blue, and you can see that the color of the sun is going to a yellowish color. In the camera, it's looking bright white, but camera was not able to adjust it white balance. That's why it's so. The sun is now yellow in color, and the sky is still blue. Now sun is going from to an orangish color, and you can see that in the sky a yellow color has appeared in the upper section, and now the lower section has turned white in color instead of blue. Now the sun has disappeared, and see, our sky is now yellow in color at the top. This is because now it's also scattering yellow light. This phenomenon also occurs during sunset, that the sky towards the sun appears orangish or yellowish in color. And to me, it's look just awesome. Like, share, comment, and subscribe to my channel. I would like to thank Aga for financial support, due to which I am able to create videos which require costly glass equipment like condenser joints, flasks, etc. If you want me to try advanced synthesis such as Grignard reaction, which involve hot plates with magnetic stirrer, three-neck flask, different chemicals, etc., you can support me financially through Patreon and PayPal. Links are given in description.